Hello, I hope you are doing well. So let's start. Spectrum number 17. Molecular formula is given in the mass spectrum, which is C3H6Br2. So our first task is to find out degree of unsaturation or unsaturation index. The formula is 2C plus 2 plus number of nitrogen atom minus number of hydrogen minus number of halogen atom divided by 2. So simply put the value 2 remain as it is. How many carbon in the molecular formula? 3 carbon plus 2 according to the formula. Is there any nitrogen? No, 0. How many hydrogen? 6 hydrogen. How many halogen? 2 halogen. Br2 is present, so 2 halogen divided by 2. So simply put the value 3 times 2, 6, 6 plus 2, 8, 8 minus 8, 8 minus 8 divided by 2, you will get 0. It means the degree of unsaturation of this compound is 0. There would be no pi bond present in this compound. No cyclic ring, no pi bond. If you look at the IR spectrum of this compound, IR spectrum is empty. You are getting the sp3ch stretch. Because the compound contains bromine, so CBr bond stretch is available over here at 1763. Carbon bromine stretch. And if you see the mass spectrum, I told you when bromine or chlorine are present, you will get M plus 2 peak. M plus 2 peak is formed when chlorine or bromine are present. Okay. So degree of unsaturation is 0. IR not much fruitful because it is saying only the sp3ch stretch is present. So look at the carbon 13 NMR spectra of this compound. If you look at the carbon 13 NMR spectra, depth spectra, you are getting 2 CH2, this one and this one. So there are two types of carbon are present in this compound. If you look at the proton decoupled spectra, still you are getting the two type of carbon. So it means there are only CH2 signal in this compound. There would be no CH, no CH3 present in this compound. Because CH2 signal negative, if CH3, the signal would be upward like this. Okay, now let's move towards the proton NMR spectra of this compound. The molecular formula, look at the molecular formula C3H6Br2. 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 Okay, so we have 6 hydrogen. Molecular formula showing 6 hydrogen, and we are getting the 2 signal in proton NMR spectrum of this compound. Okay, this integration is all this integration and this integration. This integration B is almost double to the integration of A. It means if this is a signal of 2 proton, this would be the signal of 4 proton, right? Because the integration is almost double. So what does it mean? It simple mean if this is a signal of 2 proton, this is a signal of 4 proton. So 4 plus 2, 6. So 2 proton expansion is given. You are getting 1, 2, 3, 4, 5 lines. So we are getting 2 proton pentate. ppm is round about 2.3 ppm. And we are getting 4 proton triplet. 4 proton triplet, we are getting round about 3.5 ppm. And 4 proton triplet is having higher chemical shift. Okay, now let's put out the value, how we can draw 2 proton pentate. In order to draw 2 proton pentate, 2 proton, like this is a 2 proton, now I have to keep the environment same. Again, I can't put 4 hydrogen to single carbon. So now how I can put the environment same? If I'm trying to make 2 proton pentate, so I will put 2 proton in neighbor and this side 2 proton in neighbor as well. So now this red CH2 is giving us 2 proton pentate. 2 proton pentate. Now, if you look at the molecule, and we have to draw 4 proton triplet as well. How we can draw 4 proton triplet? So CH2, again, we have to keep the environment same. CH2. So these black hydrogen, if the environment is same, this hydrogen and this hydrogen, they will give you a triplet. Now, if you look at the molecular formula C3, carbon 3, hydrogen 6, we have left only Br. So if I'm going to attach one Br this side and one Br this side, this is the structure of this unknown compound. And now, if you look at the proton NMR value, so these black hydrogen, because the environment is same, because the compound is symmetrical, so these 4 hydrogen will give you a triplet in the range of 3.5 ppm. While this 2 proton pentate will appear at 2.3 ppm. Any confusion? Now you have to draw the same structure again, and you have to write the carbon 13 NMR values, but just looking at the carbon 13 NMR spectrum. So CH2, 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 Br, and Br. So these CH2, these CH2, these are this one. They are appearing around about 35 ppm. While this CH2 is appearing around about 30 ppm. So this is the carbon 13 NMR spectrum of this compound. Again, ppm justifiable as well. Okay, if you look at the mass spectrum of this compound, you are getting the molecular ion peak. You are getting the molecular ion peak. Let's move one hydrogen, one electron from here. So you are getting a molecular ion peak at 200, 202, 204. If you remove one bromine, then you will get a peak at 121 or 123. So you can easily draw these fragments easily. So IR spectrum is also justifiable. If you look at the IR spectra told us there are only two types of stretch present in this compound because every carbon is sp3. So we have sp3ch stretch present in this compound. And secondly, we have carbon Br stretch, which is appearing at 763. So this is all about the structure. I hope you have enjoyed this session. Please like, subscribe, and share this channel. Wish you best of luck. See you in the next discussion. Bye-bye.